A marble sun, our star, miniaturized. Imagine holding the sun in your hand. It sounds crazy, right? But what if we shrunk our star down to the size of a marble? It's a mind-blowing thought experiment that helps us grasp the incredible scale of our solar system. Imagine a small, glowing marble radiating warmth. That's our sun shrunk down to size. Now, let's take a journey through our miniaturized cosmic neighborhood. Get ready for some astonishing distances. Even though we've shrunk our star, the distances between planets are still vast. But don't worry, we'll use familiar units to make it easier to understand. Let's keep going. This is when things start to get truly fascinating. Fasten your seatbelts, cosmic explorers. Tiny traveler Mercury in a new light. First up is Mercury, the smallest planet in our solar system. Despite its size, it holds many secrets and surprises. In our marble sun model, Mercury is a tiny speck of dust, barely visible to the naked eye. Imagine trying to spot it in the vastness of space. Picture a grain of sand smaller than the tip of a pin. It's almost unimaginable how something so small can be a planet. That's how small Mercury would be. Yet it plays a crucial role in our solar system's dynamics. And where would this minuscule planet be orbiting our marble-sized sun? You might be surprised by the answer. Hold on to your hats. Mercury's orbit is closer than you might think. Mercury would be zipping around our marble sun at a distance of about 12 feet. That's incredibly close in astronomical terms. That's like taking a walk around a small room. Imagine the speed and proximity. This tiny world races around the sun faster than any other planet, making its year just 88 Earth days long. That's less than 3 months. But don't let Mercury's size and speed fool you. It's a planet of extremes, with temperatures swinging wildly. This little planet is a fascinating world of extremes. From scorching days to freezing nights, Mercury is a place of wonder and mystery. Its surface is marked by craters and cliffs, telling a story of a turbulent past. Mercury, though small, is mighty in its own right. Venus, our scalding sister planet. Next in line is Venus, Earth's scorching hot sister planet. In our marble sun model, Venus would be about the size of a pinhead. Imagine a small, shiny bead reflecting the light of our marble sun. That's Venus, scaled down. Now let's talk about its orbit. Where would Venus be in relation to our marble sun and Mercury? Venus would be circling our marble sun at a distance of about 25 feet. That's like walking from one end of a school bus to the other. This puts Venus almost twice as far from the sun as Mercury. Now, let's imagine Earth. Our home planet is next in line, and it's where things start to feel really small and vast at the same time. Earth, a cosmic oasis shrunk down. Now let's find our home planet, Earth. In our marble sun model, Earth would be about the size of a poppy seed. That's incredibly small. It's amazing to think that our entire planet, with all its mountains, oceans, and life, would be reduced to something so tiny. Now, where would this minuscule Earth be in our shrunken solar system? Earth would be orbiting our marble sun at a distance of about 35 feet. That's roughly the length of a standard school bus. Imagine walking that distance knowing that it represents the vast gulf between our planet and the sun. It's both humbling and awe-inspiring. Speaking of awe-inspiring, let's not forget about Earth's faithful companion, the Moon. Section 5. Our faithful companion, the Moon's miniature dance. Even in our miniaturized model, the Moon remains tethered to Earth, just as it does in reality. This connection is a testament to the gravitational bond that has existed for billions of years. But how small and how close would it be to our poppy seed-sized planet? This question brings us to a fascinating comparison that helps us grasp the scale of our solar system. The Moon, in this shrunken scale, would be about the size of a grain of salt. It's incredible to think that something so small can represent a celestial body that has such a significant impact on our planet. Just imagine the celestial body that controls our tides and illuminates our night sky, shrunken down to something you could easily lose in a pinch. This tiny grain of salt symbolizes the Moon's influence on Earth, despite its reduced size in our model. This tiny speck of salt wouldn't be far from our poppy seed Earth. The proximity in our model mirrors the actual closeness of the Moon to Earth in space. In fact, it would be a mere inch away, showcasing the relatively close proximity of these celestial bodies. This inch represents the average distance of about 238,855 miles between the Earth and the Moon. The Moon, despite its diminished size in our model, continues to be a powerful reminder of the intricate dance of gravity and the vastness of space. even in miniature. This model helps us appreciate the delicate balance and the cosmic choreography that governs our solar system. Section 6. The red planet Mars in miniature. Next up is Mars, the rusty red planet that has captured our imaginations for centuries. In our marble sun model, Mars would be about half the size of Earth, like a small grain of sand. Imagine a reddish-brown speck, a tiny world with polar ice caps and dusty plains. That's Mars in our shrunken solar system. Mars would be a considerable distance from Earth in our model. It would be about 56 feet away from our marble sun. That's about the length of 3 cars parked bumper to bumper. It's a significant distance, highlighting the challenges of interplanetary travel, even on a shrunken scale. Section 7. Jupiter, the giant king, reduced. Now get ready for the king of the planets, Jupiter. Even shrunk down to the size of a marble, Jupiter is still impressive. In our marble sun model, Jupiter would be about the size of a pea. Imagine a small, swirling sphere, its great red spot, a tiny dot on its surface. That's Jupiter, the largest planet in our solar system, shrunk down to size. Jupiter would be a whopping 180 feet away from our marble sun. That's about half the length of a football field. It's incredible to think about the vast distance Jupiter would cover with each orbit around the sun, even in our miniature model. Section 8. The ringed wonder Saturn's tiny majesty. Next, we encounter Saturn, the ringed beauty of our solar system. Known for its stunning rings, Saturn stands out as one of the most captivating planets. Even in miniature, Saturn's rings are a sight to behold. These rings, made up of countless particles of ice and rock, create a mesmerizing spectacle. In our marble sun model, Saturn would be about the size of a green pea, slightly smaller than Jupiter. This comparison helps us grasp the relative sizes of these gas giants. Now picture this, Saturn's rings, those iconic bands of ice and rock, would stretch out to be about twice the diameter of the pea itself. These rings are not just wide but also incredibly thin, adding to their delicate beauty. Saturn and its magnificent rings would be located about 350 feet away from our marble sun. This distance highlights the vastness of our solar system. That's longer than a football field. Imagine walking that distance and realizing it's just a tiny fraction of the space between the planets. The sheer scale of our solar system, even in miniature, is truly breathtaking. Each planet, each ring, and each distance tells a story of cosmic proportions. And we're not done yet. The wonders of our solar system continue to unfold. We still have a few more planets to visit on our journey. Each one offers its own unique marvels and mysteries waiting to be explored. Section 9. Uranus, the sideways ice giant. Next on our journey is Uranus, the ice giant that spins on its side. In our marble sun model, Uranus would be about the size of a small blueberry. Imagine a pale blue sphere, tilted on its axis, representing this distant and mysterious world. Uranus would be a distant 700 feet away from our marble sun. That's about the length of 2 football fields. The distances between these outer planets are truly vast, even when we shrink everything down to this scale. Section 10. Neptune, a distant blue giant in miniature. Finally, we reach Neptune, the farthest planet from our marble sun. In our miniature model, Neptune would be about the size of a slightly smaller blueberry, just a tad smaller than Uranus. Imagine a deep blue sphere representing this icy giant at the edge of our solar system. Neptune would be a staggering 1,000 feet away from our marble sun. That's more than 3 football fields. It's mind-boggling to think about the vast distances that separate these outer planets from the sun, even when we shrink them down to this scale. Section 11. Proxima Centauri, a distant neighbor. Now that we've explored our miniature solar system, let's zoom out even further. The closest star to our sun is Proxima Centauri. In our marble sun model, how far away would this neighboring star be? Prepare to be amazed. Proxima Centauri would be a staggering 1,000 miles away from our marble sun. That's like traveling from New York City to Los Angeles. The vast distances between stars are truly mind-boggling. Section 12. The Milky Way, our vast galactic home. And it gets even more awe-inspiring. Our Milky Way galaxy, a swirling collection of billions of stars, would be a vast city of stars stretching across a distance larger than our entire planet. Imagine a sprawling metropolis of stars, with our marble sun as just one tiny point of light among billions. It's humbling to realize that our sun is just one of countless stars in this vast cosmic structure. Section 13, Andromeda, a spiral in the distance. But wait, there's more. The Andromeda Galaxy, our nearest major galactic neighbor, would be another vast city of stars, about twice the size of our Milky Way, located incredibly far away. Imagine a whole other Milky Way filled with its own billions of stars, located at an unimaginable distance from our own. It's a truly awe-inspiring thought that underscores the vastness and grandeur of our universe.